So let's do one final example together, and then hopefully you've been able to do the ones that were on the right-hand side each time. This one, you'll notice, contains 3 different elements, so that's a little different, and that's why it's towards the end. The one on the right is also different in some way, and you'll see in a moment. But we'll do this one together, and then you can do the one on the right on your own. I'm going to make a new sheet of paper over here, and I'm going to start by figuring out what my central element is. So I have carbon, oxygen, and hydrogen. If I look at the periodic table, carbon we know is right in the center, so I can make that my central element. And then oxygen is pretty close to carbon, and then hydrogen is way over here on the edge. So in my drawing, I'm going to start with carbon, and then I'm going to put oxygen. And then I can't be 100% sure whether the hydrogens would come off of oxygen or if they would just come off of carbon. So for now, I'm just going to make a guess that the hydrogens could be on either side of carbon. In some cases, you do have to do some guessing and checking to figure out what the most logical solution is. So I put carbon as the central element, and I'm going to put the oxygen and the 2 hydrogens around it. I'm going to connect them with bonds. Is it possible that the hydrogens would be connected to the oxygen? Yeah, it's possible. But the reason we pick the central element as the one that's closest to the center of the periodic table is because that element will have the most bonds coming off of it. And so very likely, it will have more atoms attached to it. Our next step is to calculate the total number of valence electrons. So I'm going to write the formula down here, COH2. And we're going to add up the valence electrons. Carbon is here in group 14, so it has 4 valence electrons. Oxygen is in group 16, so it has 6 valence electrons. And hydrogen is in group 1, so it has 1 valence electron. So I'm going to add 4, because there's just 1 carbon, to 6, because there's just 1 oxygen, to 2 times 1, because there are 2 hydrogens. 4 plus 6 plus 2 times 1 is the same as 10 plus 2, so that is going to be 12. There are 12 total valence electrons in this compound. If I subtract the bonds that I already used, that would represent 2, 4, 6 valence electrons. So we have already included 6 valence electrons in our drawing, and we have 6 more that we need to add. Okay. If we remember that hydrogen is happy with just this 1 bond, then we might consider just adding the valence electrons to oxygen. There's our 6. But then we need to check and make sure each element achieves the octet rule. So our hydrogens are happy with just their 1 bond. Our oxygen is happy because it has 2, 4, 6, 8. And our carbon has 2, 4, 6, so it is not happy. If you remember from the other example, one way that we can produce more electrons when we don't seem to have enough is by converting a lone pair to a bonded pair. So I'm going to take out one of the lone pairs that I added. I'm going to take out 2 of them because I like it better with them on opposite sides. And I'm going to convert the lone pair that was over here to a double bond. So if I add up my valence electrons, I have 2, 4, 6, 8, 10, 12. That's the total. And each hydrogen is happy. The carbon is happy because it now has 2, 4, 6, 8 valence electrons located in these 4 bonds. And the oxygen is happy because it has 2, 4, 6, 8 located in a combination of lone pairs and bonded pairs. And if you remember, there was a trick using the oxidation number. That's the number at the top here. We expect carbon to want to have 4 bonds. So when you are doing these drawings, if you have a carbon, you should expect it to want to have 4 bonds because it only has 4 valence electrons. So the way that it gets the other 4 is through bonding, right? Oxygen wants to have 2 bonds because it needs 2 more valence electrons. It only has 6. So it usually wants to share 2 pairs of its electrons. And in this case, it does that through this double bond. So if you notice that you don't have enough bonds, that can also be a clue that you need to adjust your drawing. So go ahead and take a screenshot and add it to the slide where you see carbon, oxygen, and hydrogen. This is actually formaldehyde, which is a molecule that they use to preserve dead animals. Fun fact. So go ahead and paste your picture there, and then try this last one, which is C2H4.